Welcome to section 5.4. Our objective here is I can prove and use properties of triangle midsegments. So midsegment of a triangle is a segment that joins the midpoints of two sides of the triangle. So see where this side is? Our midsegment starts at the midpoint right there and on the midpoint of this side. So this right here, our XY, is the midsegment. There's also another midsegment right here, where it's the midpoint of this side and the midpoint of this side. And there's also another midsegment right here, where you have the midpoint of this side and the midpoint of this side. We're going to be focusing primarily on this type of midsegment where you have a triangle and you have a midsegment right here. So let's say this is 8. Well, this point right here would be between 4 and 4. And let's say this side is 6, it'd be between 3 and 3. That would be the midsegment right there. It's cutting those sides in half. And this creates the midsegment. And within that, you have a midsegment triangle. But first of all, we're going to have our triangles. And we're going to look at some things about these midsegments. So you have your original triangle right here. These are the points of your triangle. Let's just do a rough sketch of that. So x is at -1, 8, somewhere right there. Y is 9, 2, somewhere right there. And z is 3, -4, somewhere right there. So this is what our triangle looks like. Something like that. And we have that m and n are the midpoints of xz. So first of all, xc and yz. So first of all, we need to figure out where that is. So m and n are the midpoints. So let's find the midpoint of xz, because that's what it tells us first to find. So somewhere in the middle of this side is going to be, let's put point m there. So what we do is we find our midpoint using the midpoint formula. So you have x and z, because that's what it tells us to do, x and z. And we're going to use our midpoint formula, which is x2 plus x1 over 2, y2 plus y1 over 2. And this will give us our midpoint. So when we plug all that in, our x and our z, we get this. This is our midpoint at 1, 2. 1, 2. And it looks like they're actually putting it on the other side. No, they're putting it right here. I just didn't grab my graph very well. It's right there. It's M. Now, where's our other midpoint? It's going to be along this side, YZ. So let's put N over there, and let's figure out what that is. We're going to look at Y and Z. And we're going to plug it into the midpoint formula. And we get 6, -1, which is somewhere right here, N. And let's connect those. And you don't have to graph this. This is just great visual to see. So this is the midsegment, it looks like. And now we need to show that MN, what we just drew, is parallel to XY. Okay, well, it looks pretty parallel, but how can we check that they're actually parallel? Well, we're going to look at slope. So we're going to use our slope formula. If you don't remember the slope formula, it is y2 minus y1 over x2 minus x1. Okay, so we find our slope of mn, and we get -3/5. And we find our slope of xy, and we get -3/5. So since they're the same slope, these are parallel. So we confirmed that so far. Now we also need to show, because that's what else it tells us to do, is mn is half of xy. Well, how are we going to show that it's half of it? We're going to find the distance. So for finding the parallelness, we're going to find the slope. To find this, we need to use the distance formula. So two formulas that we're using in these types of problems. So my distance formula, if you do not remember it, I'll write it down here. Square root of all the things, x squared, or x2 minus x1 squared, plus y2 minus y1 squared. So mn, we plug that in first. We get square root of 34. xy, we plug that in, and we got 2 square root of 34. So if you look at it, xy is twice the size of mn, which would indeed show that mn is half of xy. Okay, we're going to do it again for this one. So we have all of our vertices of our triangle there, and I'm going to write them off to the side here. So we have r is -7, 0, s is -3, 6, and is it t? Yes, t is 9, 2. Okay, now we have m is the midpoint of rt. And now we're going to find the midpoint. Okay, so for finding point M, we're going to find the midpoint of R and T. So remember your midpoint formula. You're going to have the two x's added together, divided by 2, and the two y's added together, divided by 2. Okay, so then you have -7 plus 9 is 2, divided by 2 is 1. And then 0 plus 2 is 2, divided by 2 is 1 again. So my coordinate for point M is 1, 1. Okay, now let's find our other point. Our other point is N, which is the midpoint of ST. So N is the midpoint of S and T. So we're going to plug ST into the midpoint formula. We have our x's added together, divided by 2. And our y is added together, divided by 2. So right here we have 6, divided by 2 is 3. And right here we have 8, divided by 2 is 4. Okay, now let's find out what else they want from us. We want to show that MN is parallel to RS. So we're looking at MN and RS. We're going to show that these are parallel. MN parallel to RS. Using what formula? The slope formula. So for the slope, we're going to first find, let's find MN slope first. So we have y2 minus y1. So let's make this x2, y2, x1, y1. That's a really bad y. So we have 4 minus 1 and 3 minus 1. We get 3 over 2. Cool beans. Now let's find our slope of the other ones, and let's label. So for RS, we have 6 minus 0, and then we have -3 minus -7, so it makes a plus. And then 6 divided by 4. Ooh, that can reduce. So then I have 3 over 2. And since we got the same slope for both of these, we can agree that these lines are parallel. Okay, let's see what we have to do next. We also have to show that MN is half of RS. So we have RS again, and we're going to use the distance formula. We're going to find the distance of each. So let's find the distance. So we're showing that MN is half of RS. Really sad looking R, but there you go. Okay, and then we're going to just plug into the distance formula. Let's find MN first. So we got square root of all the things. We got x2, 3, minus x1 squared, plus y2 minus y1 squared. Now remember, when you do this, you cannot just cancel out those squares with the square root. You have to do everything inside the square root first. So 3 minus 1 is 2. That's choking on a Skittle. Okay, so 3 minus 1 is 2. Square that, you get 4. Plus 4 minus 1 is 3. Square that, you get 9. And so then we add those up, you get square root of 13. You can just leave it like that for now. Now let's find RS. And we have the square root, and then x2 minus x1 minus negative makes a plus. And then we have y2 minus y1 squared. Zoom in so you can see. So now we have 4 squared, which is 16. And then 6 squared, which is 36. So then you have 52. same as 4 times 13, and the square root of 4 is 2. So you can see that this is twice the size of this, and that shows that right there. So make sure you're reducing when you do those. If you don't remember how to do this, just practice some on IXL or let me know. But there you go. So this is actually true for every midsegment. Every midsegment is going to be parallel to the other line there. You can kind of see which one it would be parallel to. And then the midsegment is always going to be half the size of that parallel line. So if this was 3, this would be 6. If this was 8, this would be 4. If this was 16, this would be 8. If this was 1,000, this would be 500. Okay? So looking at this, if they want us to find BD, the length of BD, ignore all the angle measures. We're just finding BD. This right here. So if this long one is 17, we're going to cut that in half, and we're going to say, oh, well, that's 8.5. 8.5. Easy as that. Okay, and now they want us to find CBD. So find the angle CBD. It's right here. That one. So we know that we've got parallel lines here. Right here and right here. And you can consider this a transversal if you remember that. So this angle is going to be the same as this angle. Can't go off of that much. What if we make these parallel and use this as a transversal? Better yet, if you look at this, you actually have all these different midsegments. You can make this midsegment parallel to this, which would capture this angle that we already have and this angle that we're trying to find. And you can make this your transversal. So if this one's 26, this one's 26 because of alternate interior angles here. So this is also 26. So play around with it, figure out where your parallel lines would be and where your transversal would be. You guys learned all these angles before, but it's the same type of thing. So let's look at this one. We have J, we're trying to find JL. And wow, that did not zoom very well. Okay, so JL is right here. It looks like across from it we have 36, so this is probably going to be twice the 36, so it's going to be 72. We just did 36 times 2. That's all we did. Now let's find PM. So we got PM right here. Look across from it, we have 97, so we're going to cut that in half. So we get, what do we get, 44? Oh, 48.5. Party foul. Oh yeah, then no, that's definitely not going to be 44. So 48.5. You just divide the 97 in half. Okay, MLK. We're looking at this angle right here. We have this angle, so I'm probably going to mark that and make reference of it. We need to figure out some sort of parallel lines and a transversal. So I see that I have a side and a mid segment right here. So those can be my parallel lines, which would probably make this my transversal because it's passing through, and see how those are kind of boxed in. So that's what you're looking for when you're doing these type of things. Now what type of angles are those? They're corresponding angles, and corresponding angles are congruent. So this is also 102 degrees. They used, what did they use? Similar triangles, that's a lie. Ignore that. Okay, in an A-frame support, the distance PQ, and if you're not sure what the A-frame, it's usually, the roof of houses are usually built like this. They use A-frames to kind of make that little peak of your roof. The distance of PQ, this, is 46 inches. What is the length of the support ST if S and T are the midpoints? So if these are the midpoints, then that would make this a midsegment, which means that in order to find ST, all I need to do is take PQ and divide it in half. So this would be 23. 23 inches. Simple as that. Okay, now let's look at this one. So let's see. Check Anna's result to see if it's correct. To check it, she measures a second triangle. How many meters will she measure between H and F? So this is what she has. She measured all the things. And if you look, you see 640 here, 640 here. That means that this H is a midpoint. And I have 1005 and 1005, which means that F is a midpoint, making HF a midsegment. Okay, so we know it's a midsegment. Now let's see here. We have HF, AE. Okay, so she told us that AE is, it's kind of hard to see, 1,550. So if AE is 1,550, how do we figure out what HF is? We just divide it in half. That's all we're going to do. Or times it by a half. Same thing, but you get 775 meters.